Okay, so let's review the objective. The objective is to determine the relationship between Newton's three laws and rocket power by participating in our little engineering project. And I'll prove my mastery of this relationship in writing by completing the handout. So you'll complete the handout as you go along. Obviously, if you can't remember the answer to the question, in your notes that you took, and you can obviously work on it together. The essential question is, why were Newton's discoveries so critical? All right, so we have, everybody has their teams. Does everybody remember their jobs, or do you need these back? Okay. So the first thing we're going to do is you're going to send your materials person up. He's going or she's going to collect the materials. The only thing is, everybody gets permanent double-sided tape if you need it, if you'd like to use it. Okay, obviously, probably you need it, right, or I wouldn't be giving it to you. So, but I only have 4 of them, and there's not a lot of it, so please use it sparingly. Also, everybody will get a straw. I got the colorful party ones. But they have the flex. So I'm going to cut it off at the flex, because you can't have that flex part in there. If you need to make it shorter, that's up to you, but they'll all be cut off where it flexes, all right, because that will mess you up. Okay, send your... For a second. Remember, it's a race. All right, we set the test tracks up before we went to specials, and we know where the starting line is, we know where the finish line is. And everybody has the same amount of materials, except remember, there's only 2 pairs of scissors and not much tape. So please use it sparingly. Here's the grading system. It's all up there. We're talking about the objective. Okay? I'm not answering any questions. 2 people on your teams are engineers, right? That's why they're there. If you have a question, ask the engineer. I will walk around and hand out, while you get started, I will hand out the handout that you need to be filling in as you go along here. All right? And if you do the handout, if you at least just look at it, it will give you some hints as to what you need to do. All right? Any questions? Anybody have any questions? Good, because I'm not answering any. All right, here we go. Go ahead. Race time is 10:40. Now you want to get it on the track.
So do that. You too. Alright. So, yeah, I think we got blow this up, use the tape to put it like this, and then so we can go like that.
One thing I will tell you, you got to hold it straight. Actually, kind of level. But you're off to a good start.
Yeah, that's just going to mess us up. So I could do
Okay, rules question. Rules question. The string, you're going to have to hold the string fairly level. You can't tilt it all the way up and, all right? So, it doesn't have to be perfectly level, but we're going to hold it pretty level.
Yeah, you're gonna have to blow it up and put it on the tape and put it on. Undo it. You want to show us? I was doing it. Yeah, I don't want to undo it. So there you go. No, if you undo it. No, this tape all about words. No, don't blow.
How would you blow it with a straw? How's that gonna help you go faster? Just blow it up right now. That'll tell you. With the tape. Now we're gonna use this tape.
Yeah, actually,
No, a little bit more. Yeah.
There.
We'll probably, do you know how to test it?
Hold up, we gotta test it. We gotta test it.
watch out.
Wait, Mr. Cooper,
That's why you have your test strap.
yeah, we need the tape.
Oh, done. Alright, that's good, that's good. Give me the tape and see what tape it's gonna be a race.
What's the tape? Let me see. Hey, watch out. Don't pop it. Alright, hey,
Wait, watch out. Watch. It's gonna go slow, watch. It's gonna go slow. 2, ready, set, go. Yeah, you moved up too big.
now you just gotta take it off the
First you gotta go.
Worked on. What's one of the things, what's the last two steps?
Analyze information.
Analyze and what else?
Interpret.
No. The last
report the results.
Make it better.
No, not the scientific method, but the reevaluate, analyze. Okay, reevaluate. You should be doing the whole reevaluation here if you're having trouble.
Is it here?
We need more air, that's why.
Okay, remember that the start line is right here, it's right where the two cabins come together on the back wall. So make sure you get from there to the cabinets.
No, you put it through and I get it out.
No, that's not the start. It's not even to pull the string up. Just a tape. What's the tape? You're not
Rabbi, where's the tape?
Good, Jesse. Go.
Tape it all
Oh, that's why it stayed like close like that. That's why it's spinning.
I got it.
Let's come back here.
Alright, we had it.
This thing's
Marina, help me.
Hold the tape on.
Marina, help me over here.
It's gonna go the other way.
Two teams just did the same thing. Cut the tape before you put it on the balloon. Don't cut the tape against the balloon.
Oh no, we were just taking the tape off. Oh, you got new balloon.
It's permanent tape. It says right on there, permanent.
Put a name on it.
Oh, let's put a face on it. You guys are copying me. You guys are copying me. Can't take it off.
Get a scissors.
He said we're supposed to get a new string. It's not working.
Okay, take a break.
Is that? Can you get the
If
scissors?
you want to test it, go ahead. Not back.
Above the not below. The tape. No. See, even this side, even this end of the string.
I know, but just tied up now that I got it.
No, this side of the string too is missing.
You're even covering it.
Do double knot.
Tie it twice. That's slow. You guys are slow.
A motion and rest stays in.
Okay, body arrest tends to want to stay at rest, and a body in motion tends to want to stay in motion, unless what?
Unless interfered with the unbalanced force.
Okay? How about what's number 2?
Motion and
Look up here. What's the second law?
force equals mass times acceleration.
Okay. What's a kind of a more common way to say that?
Okay, that's not. No.
Look up here. Oh, hold the balloons. Look up here. What's the second law? Force equals mass times acceleration, but put that into words. What's
A motion and rest stays. Wait, a motion, object in motion stays in motion.
that's law 1. We already did that one. What's 2?
Wait, what is it? Mass times acceleration?
No, yeah, mass times
That's
acceleration.
okay. Say it again.
More mass, more force.
Okay, so the heavier something is, the more force it takes to move it, right?
Are we allowed to put weight on it?
What's the third one? You should know the third one pretty easily now. What's the third one? Say it louder, Elijah.
Every action has an opposite reaction.
Every action has an opposite reaction.
Has it, right, has an equal and opposite reaction. Which is what? You gotta, the first law, you gotta overcome it, right? Because your balloon is what? At rest. So it doesn't want to move, as some of you are finding out. Okay? The amount of force on the second law, how much force do you need? And the third is the obvious one. What's the action and reaction? All right, let's go. Right stop, right where you are. I think we need some reevaluation there.
Hold up, the tape is like.
Yeah, what is she doing?
Ready? Set. Go. No, we're starting from here.
Hey, go. That's so.
Been working on the handout. Everybody take a minute right now and as a team complete your handout. Alright, so I'll take a couple minutes, complete your handout. And then there's 8 questions on it. I have a question number 9 that you need to fill in when you get them down a minute. So run on back. In our balloon rocket race kind of experiment, we have, where does the first, raise your hand, how does the first law come into effect?
You're using the opposite energy to put whenever you need a rest so it can be moving.
Is that the first law? Chris?
That like the balloon probably, if it had air in it, it would stay going, but if
Okay.
the air runs out, it stops and it hits
Okay.
No force.
Alright. So we have the first law, we use the second law obviously because we need force. We talked about acceleration. We talked about gravity. What's gravity doing in the case of this rocket? Brian?
It's bringing the object
It's bringing the object. Alright, it's pulling down on the object. Okay, so gravity pulls down on the object, which pulls down on the straw. Pulls down on the straw, So as the straw slides along the string, what is that creating, or what force is acting on friction? Okay? So we have the three laws. We have gravity, all complements of Newton. We have friction, we have acceleration. Anything else? I can't think of anything else. Dr. Sherman. So, we're trying to get it all covered. Now, question number 9, write down 9. There's only 8 on there. Write down the number 9. By the way, make sure your name is on there. Question number 9. Of all the things about Newton, law 1, 2, and 3 in gravity, friction, acceleration, there's probably a few others I can't think of off the top of my head. Which do you think is the most important item or law or force in this experiment? Pick just one. What's the most important? Law 1, 2, 3, gravity, friction. In terms of this balloon rocket, what is the most important? What do you think is the single most important factor?
You have to put the factors across the law.
Well, you can put down the law or the factor or. Out of all those things, pick out the one you think's most important or the best example in this experiment and put it down.
Do we have to write down the question?
No, just put down, I think this is the most important and whatever it is. Okay, so you said law 2, which is force equals mass times acceleration. Okay. How many people, and this better add up to 31 at the end, how many people put that down? Raise your hand if you said law number 2. Okay, hold your hands up. If that's what you wrote down. Don't write it down now, because you don't know if it's right. Your hand up. 6, 7, 8. So 5, 10, or 9, 10, 11, 12, 13, 14. Okay. Priscilla, what'd you put down? So you took essentially no position. You said everything's important, so therefore nothing's important. Because everything can't be important. Something has to be. Okay. So how many are over here? How many, did you all say that? Okay. So we'll call that no opinion.
Just go first, Frank. Just go. You didn't get a paper.
Hmm?
You didn't get a paper.
You need a paper.
Yeah.
Thank you. Stephanie, what's your group put down?
We put down the third law.
Third law. All right. How many people said that law number 3? Just those 5? 6?
Or no. I was gonna say.
All right, what do you guys say?
You said the first law of motion.
How many? All 5?
Yeah. Was
So 15:29, I think somebody's out of the class, right?
Yeah.
Huh? Yeah, Elijah left. It's 30, and Francisco just got a paper. So, okay. Everybody's accounted for. So it looks like law number 2 is the winner. At least in your opinion. Why do we feel so strongly about that? Why do we feel so strong about that one? Tyson?
Because if we didn't have no acceleration, say if a rocket just took off, it would be the same speed that it took off from, except just keep on going like faster and faster and faster.
Okay. Chris?
Well, like the balloon, we feel like the force is the air in the balloon pushing off, so the drop will go to the other end. So we feel like that's acceleration creating acceleration.
Okay. So the force that you need, how big you need to blow the balloon up to get the mass, which is kind of really just the straw in the balloon, okay, to get it to accelerate to go forward. Okay. Okay. It's not what I would have thought, but I can see your point. Okay. My vote would have been for the third law. For every action, there's an equal and opposite reaction. So when you let the air out of the balloon, what do you get out the back of the balloon? Now, what do we call that? Now, what do we call that? Thrust. Okay, and so we get the balloon moving in the opposite direction. Okay, because the force of the air coming out the back of the balloon exceeds what? The mass of the balloon and the straw. All right, so well, we're a little ahead of time. Good. Okay, so here's what we're going to do. One at a time, one group at a time. You can pick any of the stations. If you feel that one station is better than the other, you can use that station. Okay, hold on, one group at a time. I'll call you up. We're going to start with the cabinets, and I will time you. Okay, I'll time it. So when I say go, you let go. If you let go of it before I say go, guess where you want to finish? Okay. Who's your team leader? Okay, so let's just put down Saul. You guys ready? All right, hold on. Don't do anything. I'll say ready. Don't let go. I'll say ready, set, go. When I say go, let go. Okay, ready? Ready, set, go. I'll find out. Who's your team leader? Chris, Green. Green.
Wow. It makes sense.
Are you ready? Guys ready? Ready, set, go.
Make a tie right here.
Where's it at? Oh, they're going on.
Okay, guys ready? Ready, set, go. Ton of practice running. Guys ready? Ready, set, go. Guys ready? All right, here we Ready, set, go. 1.56.
That was like the same grade.
Where's my team?
I'll get to that in a second. Okay, so on this third was, and in an amazing coincidence, Saul and Chris both tied for fifth place. So they get C's.
Yeah.
However,
You get great for being the best.
however,
No one got the G. You're off the camera.
since no one got a D, and since I thought everybody's effort and everybody's interest was pretty good, Priscilla's team gets an A, everybody else will get a B. Even though we're still waiting for Chris and Saul's team to finish.
What's your
Just right now. What you do? Send that. Let's go.
I don't think I would stick with what you got.
No.
Come on, we can do it right now. We can do it. Let's do it.
Okay,
I'm willing to beat the green.
so, hey, we have a few things we gotta do before we leave, before we go to recess. So, here's the story. Let's review our objective one more time. We want to determine the relationship between Newton's 3 laws and rocket power, which we did. And we want to make sure that we hand in our quiz so that we get credit for it. All right, so everybody got at least a B, and the team that finished first, which is Priscilla's team, those 5 will get an A. Okay, listen carefully. Before we take points, we got to put the room back together, okay? Because the next class is going to get to do this experiment, but not today. They're just going to get to take the quiz. All right. So now we also see that based on the one video we saw that it's a fine line between genius and what? Crazy. Okay. And we can assume that, based on what we saw, that Newton was walking that fine line a lot of the time. But no Newton's law, no seatbelts, no space travel, no don't ride your skateboard over a rock, don't kick a brick wall, and all the things that we saw. Okay, so tomorrow we'll take a look at some more, take a look at a couple videos actually on rocketry, some of which is pretty fascinating and some of them are kind of humorous. I guess unless you were sitting on top of the thing, then it wouldn't have been that funny, but it was funny to watch. Okay, so make sure there's a textbook on every desk. Make sure you have your planner out so you can record your points. And look around your desk and your neighbor's desk. If there's anything on the floor, please pick it up. You put it there, pick it up.